Hello, everyone. Welcome to the Lesson 4 of Programming with C++.
In the last video, we talked about variables and data types. So when we created variables, we stored some values into the variables, right? What are those values? What are they called? So in programming, those values, the hard-coded values in your program are called literals. So if you have a string like this, string S, where you stored the value hello, then hello is the literal that you are using in your program. If you declare an integer type of variable a and store the value 10 into a, then 10 is the literal in your program. So if I mention literal sometime in the future, just know that I'm talking about the hard-coded values in your program. So now let's talk about some more data types. So far, we have mostly used int for whole numbers, but C++ actually gives us a few more integer types. You don't need to use them all the time, but you should know what they are used for and what sizes those data types take in the memory. First we have here is short. Short is basically an integer that takes less memory. A normal integer usually takes 32 bits, right? We already discussed that in the last video. A short usually takes 16 bits, which is 16 bits less than integer. That means it can store smaller numbers. In practice, we do not use short very often in today's world because modern computers have plenty of memory. So we don't have to save memory by using short. So for this class, you will mostly be using int for storing whole numbers. And that's totally fine. Now the next data type I will talk about is long. So the size taken by long is 8 bytes in modern computers. But before it was 4 bytes in older computers. But long was always 8 bytes. So before it made more sense to use long for storing longer numbers or larger numbers. But now you can use long as well. So all these things are not really used a lot. You can do most of your calculations using int itself, but sometimes when you need a data type that will store a larger number, just use long. I don't think you will ever use long.
A short uses 16 bits, and int jumps to 32. Long, on modern systems, that's 64 bits, and a long is also 64.
And the last one is unsigned integer. An unsigned integer takes the same memory as integer, but it only stores non-negative values. Because it does not need the space for negative numbers, it can store larger positive numbers as well. So unsigned integer is also 4 bytes, just as integer, but integer, int, use those 4 bytes to store both negative numbers as well as positive numbers. But unsigned integers only stores positive numbers.
Suppose we are storing integers using 3 bits, not 32 bits. Then how many unsigned numbers can we store? We can store from 0 to 7. But if we are storing signed numbers, then the first bit always represents the sign. 0 represents positive number and 1 represents negative number. So we can store from -4 to 3.
So for unsigned integer, you can use the whole space for storing positive numbers only. This will be easier for you to understand when you will learn how to convert a binary number to a decimal number, and then I will be able to explain how unsigned integer numbers can store more numbers than signed integers. So that's all I can say for now. Later on, I will explain this better with the help of binary to decimal conversion. But for now, just know that unsigned integer is for bigger ranges of positive number. Now, these things I have already discussed in the last video. The first step when we create a variable is variable declaration. So if you think of a proper definition for declaration step, it is a statement that associates an identifier with a data object, a function, or a data type so that the programmer can refer to the item by name. So if we write what is a data object, what is a function, all these things we do not know yet. We will get to know them as we move forward in the class. For now, you just know this data type. So the statement that associates the identifier, which is the variable name, with the data type is called variable declaration. And we do the declaration like this. First, we mention the data type, then we provide the identifier for that variable or the variable name. And up to this is declaration. This declaration step is the first step that you do, and you do it only once. Let me repeat that once again. We do that only once in our program. And now once the variable is declared, you can use it anywhere in your program as many times as you want. You can store values into the variable. You can replace the values that are already there, anything that you want. But this declaration happens only once. Now the next thing is variable, which is a memory location with a name and a data type. So whenever you are creating a variable, you are allocating some memory for that variable, and how much memory is allocated for that variable depends on the data type that you have specified for that particular variable. Now the next definition is assignment. That is assigning a value to a variable. That step is called the assignment. We saw examples of this in the last video as well. Here we are storing some value into a variable, and this assignment step is done by this assignment operator, which is the equal sign. Okay, so this step is the assignment step, where the variable actually gets some value or some literal. It can be literal if you are typing the value, or you can get the value from other sources that we also saw in the last video. It can be user input, it can be file. Okay, so this is the assignment step. Now we will see what happens when we create variables and we do not do some assignment at all. Okay, we will see examples like that here. So let me create a variable int a, and I will store some value into it, say 5. I'm sorry, I have given 2 equal to's. And now let me print the value of a. So if I print the value of a, what will I get? I should get 5, right? Yes, that's what I am getting. Now what will happen if I just remove this line? Let me comment this out. If I add this to slashes, this particular line of code will be treated as a comment, and it will not be read by the compiler. So that's how you can block parts of your programs that you have already written, and the compiler will ignore those parts. So here I am just ignoring this line of code, and I'm still printing the value of a. You can see that my editor is already giving a green line here, and it is telling me that there is some problem. But even if I ignore that and try to print the value of a, let's see what happens. I am getting errors, but I declared my variable. I declared it, but I have not initialized it. I have not stored any value into the variable, but I am still trying to print the value of it. So that's why it is giving me errors. It is telling me using uninitialized memory a. I have allocated some memory for a, but I have not stored anything into that memory. So it is an empty memory space for me right now, and I am trying to print the value that I have there. So that's why I'm getting an error. And if I take my pointer here, let's see what it is telling me. It is telling me using uninitialized memory a. So here also it is telling me, even before I compile my program, my IDE Visual Studio is already telling me that I am using some uninitialized memory for a. So you cannot do things like this. Now you guys already learned about creating variables, assigning values to variables, how you can store the value of one variable into another, right? All these things we have already done. So let's just go over that once again. Suppose I have a variable like this, int a equals to 50. You know how I can store the value of a into another variable that I will create now. Suppose I create a variable, say float b, and I want to store the value of a into b. How I can do that? How can I do that? To do that, I will just do this. I will use the assignment operator and store the value of a into b. And let's try to print the value of b now. See what we are getting. The of b is this. Okay, let's print this. See, I printed the value of b, and b got the value 50. That's how you store the value of one variable into another. Now we will play a little bit with the assignment operator right now. Let me assign some value into this variable called b. I have used float here. I could have used double as well. So that's up to you, whatever you want to use. I can store some value like this, 65.99, and then I can create a constant, and the data type for that constant is float, and I'm naming that constant as k, and I'm storing some value 44.5 into this constant. Okay, so now first let me print the values for, I have missed the s here, const. Now let me print the values for a, b, and k. Let me print a equals to, then b equals to, and then k equals to. Okay, now let me print the values and see what we are getting. It should be the values that we have just assigned. A is 50, b is 65.99, k is 44.55. Let me remove the spaces here and add some spaces here. It will look better. Yes. Now I will do some assignments and we will see what we are getting. Now the first assignment that I will do is I will store the value of a into b, and I will not actually store the value of a into b because I will store k into a. Obviously we cannot assign a new value into k. So let me just store the value of k. Why cannot I assign a new value to k? Because k is a constant, so I cannot change the value anywhere in my program. So I'm assigning the value of k into a variable called a. That I can do, right? Because a is a variable. And then I am assigning that value back to tell me what will be the output now. If I print the value of a, b, and k after this assignment, what will we get after assignment? See about after assignment. What should be the value of a, b, and k now? So as you know, C++ always reads these kinds of expressions from the right to the left. So first it will solve this part. So the value of k will be assigned to a, and then the value of a is assigned to b. So what is our value for k? K stores 44.5. So if we print the value of a, it should be 44.5, right? But we will not get that because a is int. So the decimal part of k will be truncated. So a will only get 44. And now when I store the value of a into b, that decimal part is already truncated out. So b will also get 44 only. So let me run this code and see what we are getting. See, k is still 44.5 because we have not changed its value. We cannot change because it is a constant. B got 44, a got 44 because a is integer and this assignment here, that is executed first. So a got the value 44 only. And since b got the value from a, it also got 44 only. Okay, so when you are doing these kinds of assignments, keep these things in mind.